All right, now I should be recording. Okay, welcome to week 3 of the ELT class. Yep. All right. So, I just finished grading both of y'all's papers. Much better than they were the first week. Few minor adjustments. Suggest downloading that copy, integrate them, and fix that a little bit. But yeah, other than that, just a few couple minor things. I did have to make some changes to header information to make it more accurate to the APA format, but that's fine. Okay. This week is gonna be about how manipulating from target to target, transforming that data. Remember, you got to do your discussion boards as well. I'm happy with the way the discussion boards worked out so far. This case is this week. The question is the advantages and disadvantages of a distributed database management system, and what that means is a distributed database management system has to do with basically a system that controls or manages transactions from remote different databases and keeping those transactions across all those different databases in sync such that the order of transactions are known and or the ability to support those or updating real-time information is handled in an efficient manner, right? So like Amazon, they have multiple regional databases that handle things like pricing, inventory, individual warehouses with their inventory that feed up to a regional database front end for inventory that's used by the website for selling. So those are all types of, that's the type of distributed database management system, for example, right? So, but in some cases, those kinds of structures are not necessarily useful because they can add so much extra complexity and or overhead and processing time that you lose some of the real-time aspects of your transactional database because you have to have constant syncs between across multiple environments. So anyways, I want you to research online the advantages and disadvantages, then provide 2 examples, one for each of what would make sense in that context. All right, both for and against. So there's a data transformation process video I'd like you to go watch. Here's the link to it. A good journal article on reading from on data mining for this sort of stuff. This is useful to do. It's something I found while I was actually doing my own doctoral research. So, because I was deciding at the time if I wanted to get into data warehousing or cybersecurity, and I was trying to split between the two early on in my doctoral. All right. So this week's assignment, I want you to basically go through the process of describing the specific rules and functions that you would use to doing the transforming, the extracting, and why, right? So try to include some screenshots when you can. I understand that one of y'all have gotten the MySQL database to function correctly, and the other has not, and I have not. So do the best you can in this context. I'm willing to accept however that comes out, but basically create a set of rules. Those rules can be pseudocode. They can be step-by-step instructions on what it would take to fix the data, what you're looking to do with the data, what it is you're trying to remove the data to get it so that the source, if it's dirty, to fix it into the order you want it to be and to validate that data, right? So basically, I'm okay with you using pseudocode to explain this process here. So, or if you want to do it in MySQL and you can do it in MySQL, go for it. I'd actually like to see that done for the first time by one of the students. This is the 3rd time I've taught this class, and we have one student that in this particular session has successfully used and got MySQL running out of the 3 sessions. So in either case, go through this process, how you would do it, write up the process about what you want to do it, the rules and the restrictions you're going to do, and how you would get the pseudocode to actually work. So, so data generally is the output of an existing system, right? So in this case, it's going to be reflected as, so it can be XML, it can be SQL, it can be XML, CSV files, fixed with text files. Any of those are fine, right? So what it is I want you to work on building the logic so that we can properly process that data. In the case of having already built XML data list in that context, that particular activity helps feed into this greatly already. But definitely try to add into three sections and how you would go extracting that data information, what you're going to do with it, how you're going to make it useful, and pseudocode's fine for describing the process by which you want to be able to do it. So in this is I expect you to show how you would go about parsing the data, saving that data, updating the data, deleting functionality. If you want to do deletes, that's fine too. But really, your goal is to figure out what would be the outcome of the data transformation itself. So some of these expectations you see here, I want you to read through on this. I will definitely be emailing you guys the charts so you have some idea what the expectations are, but these are actually how as defined by the program, or not the program, the college, to meet the needs for this particular class. So the business plan, the business case, the process by which you're doing the work, and as need be, how that would actually work. And then ultimately, describe how you would go about QA that. If you had a Q&A team, how would that QA team actually go there and confirm that the data transformation actually worked? What it is you'd be looking for? So now the transformation process itself, right? Overall, the idea is to make it so that you can migrate existing data to new formats, new storage of data. XML, JSON, they made it so we have human readable methods by which we can store data and standardize that data formatting, which has made it quicker and easier for systems to adopt formats, to build standardization into the formats, to migrate data from one to another. All that stuff has been done with the cases of JSON and XML, right? Back in the old days of databases where everything was binary, locally controlled, and built custom to that database type, that migration process was a lot harder to achieve because they didn't build in the ability for you to leave their database structure to go on to other systems or other vendors with their information. Instead, they made it so that the transformation process was typically linear in that it went from one version of their software to the next version of their software. And that was problematic in the fact that people would build lots of information, especially in the scientific world, that ended up being able to be unusable to transform as newer systems got on there. So we were stuck with having to keep old systems in place that can do the work. There's still Windows XP systems out there that run databases because there's no good way to migrate the data. Now, if you ever wanted to get into a contractor business scenario, there are people out there who specialize in some of those old databases and make a lot of money migrating information from old systems and finding ways to build in hooks into that old software in order to convert it over into something like a CSV or JSON or XML so they can import it to modern databases, right? So there is a business case for people doing that as highly paid contractors, contract work. But so, or at the same time, because of that same problem, we have had not even gigabytes or terabytes, but like probably exabytes of data at this point that have been permanently lost to just old systems being unable to migrate data from databases. And people have just given up trying and or just forgotten about it. So we've actually had massive amounts of informational loss over the years from the 80s and 90s because of that inability to do that transform. So, and that's why these new formats and new standards were created so that we could build standardization and allow multi platform usage of similar things to be adopted quickly and efficiently. So, and as time's gone on, we've expanded into complex DD and BMS systems that actually integrated into data transformation. It allows you to now take what used to be months to years to transform between versions of databases of very proprietary systems like Model 204 and the IBM process on VAX VMS and or the original Access databases. A lot of other custom ones out there. It used to take months to years to convert between versions of even the same vendor. Now, because of standardization and data transformation, that can take days to weeks. And nowadays, with more standardized formats and the adoption of that, it's helped to allow multiple vendors to support commonality across multiple systems, allow you to put front end stuff, allow you to build in compartmentalization into your data, containerization into the data, allows infrastructure to build reusable systems that can be rapidly deployed and just reconnect to sources of data, and your newer versions of software picks up where it left off, and the XML provides, say, the structure by which it understands the data source it's going to be reading from. It allows it to then use multiple data sources and dynamically use that in such a way so you have all those different sources of data, sensor data, for instance, or customer data collection, or multiple things that are just accumulating stuff in like point of sale systems. And you can have front ends now that rapidly read all that in, understand its ICD as of sorts by the way of the JSON or XML layout, and just integrate it in dynamically and smoothly in such that you can then use all those different sources in rapid migration and standardization. So for the use into that. So yeah, it's been some of the benefits we've now experienced in this world. Transformation of it. So really the thing is you extract the data from all the different locations, different sites. Apparently my notifications decided to be popping up all of a sudden. Go away. Okay. So the thing is you take all those different sites. They could be OLTPs, they can be sensor data, they can be insert your Internet of Things device here problem, right? They all produce data. So the thing is to extract the data from each of those sites through your ELT system. It'll transform that data to something that can be loaded, and then you can go directly writing into your data warehouse so that you can fill out your data lake such that you can start storing all the data that you ever want to have about your company, your business, all your devices out there, and you have a centralized location, or even maybe a decentralized location if you want to have a decentralized data warehouse that allows you to then collect all that stuff, process all that information into one place, and with the step-by-step process, you do it in order operations, you get your data organized in the right order, you get it all time-stamped correctly, and ultimately that will allow you to use and build tools that extract the data, use that data, report information on it, give you all the outputs you need to know. You can create your dashboards for your business or your boss. You can just data mine that to no end in order to improve your ability to make decisions later on, right? So that's really why we extract information, all the sources. We transform that information to something that's useful, integrate it all into one bigger warehouse or data lake, and then be able to build the process by which we can use that data into such that to build to build information we need to know. And it's always good to make sure you don't omit useful information, right? So quality needs to ensure you have and use the correct information across the board, all of the information across the board, and not cause issues such that nice little tidbit of information as I put this link in here. It talks about how the Oxford comma cost Maine millions and millions of dollars because they didn't correctly process how work should be done, right? And you can read into it. It's kind of interesting because it comes down to lawyerism in that case, or legalistic understanding of how things should be separated and utilized correctly. But But overall, the extraction process is easy. It's the transformation process that's generally the hardest of the ELT bit, right? So getting access to the data, learning how to get the data, how to read the data, once you got that down, it always will be the same unless something changes on that end, which is producing that data. In which case, there should be an ICD that justifies it, or it should be like additions of information, or maybe you need to go check because suddenly it's producing garbage data that you need to go fix because the sensor went bad. But so once you get the information, getting that information should always be consistent, should always be the same format coming from it, how you're reading into it, right? So at that point, then it's trying to get it so that all those different disparate sources are transformed such that all the information can then be integrated into something that is cohesive. And that takes a lot of planning, right? So you have to understand what's coming from, what you're getting, and learn how to then integrate all those pieces into something. Now, you can do that by loading it all into memory, reading through the data, then writing it out to a single format. You could do it by running various processes, one for each of those different types of sources that then puts it into a format you like, which then integrates it and then writes it out. But the thing is that it's all about setting it up and understanding the path and how to use your data sources and what your end goal is and what you want your final data to look like. So all that does is it helps you predict trends, it helps you predict data, it helps you sources, helps you with business logic, it helps you in the whole process, right? So that's why in the process of transformation, you have to have a set of run rules of how you're going to produce things. How is it going to look like in the end? What is your sources are rules on transforming if you had to change like column 3 that every time it mentions the word business, you had to change it to company, right? Just so you can normalize your data because you had other sources you decided that were using company correctly, but in your original data sets, you had business, you had company, you had location, all those different things, but they're all being treated as if they're same. Well, sometimes your data transformation is literally like a search and replace type activity that goes live with every time you read a record from that site. So that's why that transformation can be difficult because you have to build your set of rules in there to make it so that it's converting your old data to your new data format. And sometimes it's like, well, maybe it's like every mention of this location in, say, Hawaii, you have to add in a dozen pieces of information into your overall record because you need to figure out if it's a location in Hawaii, is that in a particular beach or a particular city? Does it matter from a building or address perspective? And that stuff needs to be fleshed out into your final data because maybe you're going to be adding more sites in Hawaii, right? And you can't treat every site in Hawaii as being identical. So when you transform your data, you have to go like, oh, are these at this timeline or these periods meant this thing? Now it needs to mean this thing as opposed to this thing, right? So transform your data in that way, and that way you have everybody else. Then your entire data lake needs to understand that so that it can expand out with all the correct information, especially as you consider growth. Now, the simplification is also important because once you get it down where your data organization is understood and handled, and you can QA the auditing of the transformation process, the idea is make it idempotent or immutable, such that you can make it so that your truth source of your data is now undisputably truth, right? Or it cannot be changed without going through literally making another transformation, or you're adding to it via an approved, vetted, and process by which to do so, right? So all that being said is like building good practices, good source. You make sure all your sources are converted to become good data, and you filter out bad data. You transform the data as needed to be, make it from useful data to the complete set of data that you need to be useful, and then you get it all integrated in such a way that you have a truth source that becomes immutable. So ICDs are good for this. You can break them down to different functions. If you have a lot of abilities to use reusable code in that transformation, that's great. That's one of the best benefits of object-oriented programming in this context, or scripted languages, such that you can reuse the same functions to do the same types of data transformation with some variables being involved. That way you can maximize reuse in this case, because that ensures better likelihood of you having your end product being successfully integrated and consistent. So also make sure that you understand raw data. The good data has meaning, provides context, it's information you can useful, and bad data is generally garbage, and you need to figure out how to find the bad data, fix that data to make it good if you can, or to eliminate the bad data because it's causing you garbage. And that could be any number of sources. It could be data stored in a thing, or it could be a bad sensor, or a sensor went bad. It could be a locational problem. There's any number of things you have to do to dig in that, right? But with good data, you can then understand how to build trends. You can understand how to build history and context to all your data, and to then give clarity and meaning. And in some cases, you even build metadata that helps you to define how you're going to store and record that data, such that you can utilize it for future purposes, right? So, yeah, so data mining is the process of extracting data from things, and then you optimize that data through transforming the data transformation, optimize it for transaction, optimize it for analysis, synchronize it, scrub the data, make sure it's good data, load it into your data warehouse. You now have an immutable source of data, and ultimately, you now have a place which you can build all the reports and everything you need in order to build your business based upon. So, like I said, I'm going to send you all these charts. You can read them. Definitely go through expectations. Let's go down. Here's your list of your assignments, right? These steps are what you're expected to be able to do. The expectations here are what I extracted out as the instructor from the instructor guide on what I expect to see from your stuff, at least being addressed to some extent inside of your paper, and or providing the path by which to address those kinds of things, right? So, but other than that, I've been happy with the stuff, and I think we're on a good trajectory towards doing this, and I hope you guys continue to work and doing good progress. Do good work. All right. With that, I will listen to you guys, or I'll hear from you guys next time. And have a good week.